Hi, my name is Muhammad Amein bin Manap. I'm from Group 8 with Seow Yun Yi, Nurin, Iman and Syahmi Asyarf. We will explain about the measurement of jet force. First, the abstract of this experiment is the jet force is the exhaust from some machine like in the aircraft propelling the object itself in the opposite direction due to the change of momentum. In this experiment, two different types of deflector was used, which are flat plate and hemispherical plate. A set of weight also were used to calculate the force exerted on the plate. The objective of this experiment is to compare the force exerted by a fluid jet impinging upon a flat plate or hemispherical surface with their theoretical value. The introduction. Moving fluid may exert force on object in contact with it. The force can be determined by using the Newton's second law or by the momentum equation. The force exerted by a jet of fluid on a flat or curved surface can be resolved by applying the momentum equation. According to the equation, particle in fluid momentum change when velocity, magnitude or direction change. The value obtained on both deflectors are different since the shape is not the same, which lead to the difference in angle of water leaving the deflector.
Next, I will talk about the theory of the experiment. A jet of fluid when impinging upon a flat plate or a hemispherical surface generates a force due to the change of momentum of the fluid according to Newton's second law of motion. For example, when a velocity of water from the jet nozzle with diameter d strikes on a flat plate or a hemispherical surface, the rate of change of momentum produced and its magnitude is the same with the force exerted on the surface of the flat plate or hemispherical to support the water jet. The force generated by a jet of water when it strikes depends on the shape of the surface. Figure 1 and Figure 2 depict a jet of fluid issued from a nozzle of diameter d, moving vertically upward with velocity v1 and strikes a flat plate and hemispherical surface respectively. The jet is deflected by the surface of flat plate or hemispherical through an angle of theta and leaves the surface with velocity v2. The theoretical force is generated when a jet of fluid strikes a flat plate is F equals to rho a v1 squared minus rho a v2 squared cos theta. As the theta is 90 degree, thus v2 cos 90 degree is equal to 0. So the equation can be written as F equals to rho a v1 squared. For a hemispherical surface, the theoretical force generated is F equal to rho a v1 squared minus rho a v2 squared cos theta, and the angle is 180 degree, so v2 cos 180 will equals to negative v1. Thus, v2 is equal to negative v1. So the equation can be written as F equals to 2 rho a v1 squared. F is a theoretical force exerted on the flat plate or hemispherical surface, with a unit of Newton. A is the cross-sectional area of nozzle, rho is the density of water, theta is the angle of water flow after impact on a flat plate or the hemispherical surface, v1 is the velocity of water jet before impact on the flat plate or hemispherical surface, while v2 is the velocity of water jet after impact on the flat plate or hemispherical surface.
Okay, next I will talk about methodology. So for this experiment, for the apparatus we use jet forces measurement test bench. So the jet forces measurement test bench required weight position, deflector, nozzle, tank, lever mechanism, water supply, water drain, sliding valve, volumetric measuring tank, main switch box, and flow control valve. Next, we'll go to the step of this experiment. So the first step is determine two different type of deflector, which is flat plate and hemispherical surface. Next, remove cover together with lever mechanism. Next, assemble the tested deflector. Next, place the cover with assembled plate at the lever mechanism back into tank. So next, tighten the 3 screws to the cover, which is this screw, the black one. Set the pointer to 0, which is 0 knot, by adjusting the screw at the lever mechanism. And this one, turn on the main switch. And the next one is slowly open the control valve until maximum flow. Okay, next. So put the desired weight on the lever mechanism. This is the weight. So stop to put the weight until the pointer at the lever mechanism is at 0, which is here. Okay, so next is close the sliding valve. And the next one is this: determine the flow rate of water by recording the time required to fill up 3 liters volume of water in volumetric measuring tank. So for the record reading, reduce the desired load weight. So we reduce the weight and adjust the flow control valve, and then we stop until the pointer at the lever mechanism 0, and then again the time required to fill up 3 liters volume of water in volumetric measuring tank to determine the flow rate of water. So the sequence is repeat. So we repeat the procedure by decreasing the desired weight until the flow control valve is at minimum opening. And last one is change the deflector from plate to hemispherical surface, and repeat the procedure by using appropriate load weight. So that's all for methodology. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Me, Syahmi Asyarf, will be presenting the data and discussion for this experiment. So firstly is the data itself. In the table, we will be taking the value of measured force, volume of water collected, the time taken, actual flow rate, velocity, theoretical force, and percentage of relative error. The first table will be for flat plate, and the second table here is for hemispherical surface. As we notice in the table here, I included the actual flow rate in meter cube per second and area of the nozzle for scientifically calculation purpose. We're moving on to the discussion. The first one is to plot the graph of log measure force versus log velocity. I've tabulated the data for easier reference as we look at the theoretical equation for both plates, which is F equal to rho AV square and F equal to 2 rho AV square. And we log both of the side, we will see that the graph will be straight line. Here we have for both plates the same graph, and what we have on the slide right now is I repeat the same process to plot log theoretical force versus log velocity for further reference. Next discussion will be comparing the slope of the graph. We have plotted the graph before, so to get the slope is only for the equation of the line as stated in the slide now. We have value for both plates for measure force and theoretical force. For flat plate, we have 1.7008 compared to the theoretical value, which is 2.003. The difference is slightly and considered acceptable. Same goes for hemispherical surface. The measure force slope is 1.8414 compared to theoretical value 1.998. The difference is slightly and acceptable. Moving to part B, we will estimate the y-intercept ratio of hemispherical surface to flat plate. So as we have plotted the graph from the experimental value and theoretical value, we can get the y-intercept ratio of the hemispherical surface to flat plate when we include the x equal to 0 in the equation of the line itself. So we will get 0.758, and for theoretical value is 0.727. There are difference of 0.031, which is acceptable since error presence during the experiment. So we will move into part C. We will be compare the force exerted on the hemispherical surface with the one on the flat plate, and which one is the greater. So in this issue, in this event, the concept of momental impact causes the exerted force on hemispherical surface greater than flat plate. The exerted force depends on the shape of the plate surface. For flat plate, the velocity go to 90 degrees to the left and right after the impact the flat plate. But for hemispherical surface, the velocity will go total angle of 180 degrees to the left and right after impact the surface. And we can see from the theoretical equation itself, which is the F theoretical equal to rho AV square for the flat plate, and F theoretical is equal to 2 rho AV square for hemispherical surface. It shows that the impact on hemispherical surface is 2 times greater than force impact on the plate. So the discussion 2 is to we compare the percentage of relative error for both plate. Based on the symmetry result, the relative error for both the plate and hemispherical surface is ranging from 1.0% to 30.0%. If the relative error percentage is low, it means the jet velocity is more constant with a steady flow. Due to uneven shape of the hemispherical surface, the redirected force of the jet is not uniform and reflected back to the main jet water stream, causing variance of force output. Compared to flat plate with even surface, for jet impact to redirected, it will be more uniform and away from center point and produce more consistent result. Other than the shape of surface, other errors are also contributed, such as external weight applied on the balance, causing to imbalance force. Number 3. Briefly discuss on factors contributing to errors or inaccuracy in the experimental data and possible recommendation to improve the existing result. So number 1 is the friction force present in the experiment. Also, to overcome this error, we will calibrate the equipment before experiment to avoid reading errors due to friction. Secondly, we can use a smoother pipe, reduce the length of the pipe, and use of pipe joints. Lastly, we can also use single water pump instead of double water pump that connected in series to reduce water fraction. The second error will be time lag caused by the long distance between the water jet and reservoir tank. So to overcome this, we reduce the returns to eliminate time lag error. Some of the possible recommendation I can recommend here is to weight load is added slowly. Make sure I are perpendicular to the scale level to avoid parallax error, and carry out repeated experiment to get more accurate result. For the last part of the discussion will be suggest to application of jet impact in the industry. So the first one will be pattern wheel or hydraulic turbine. The jet of water from the nozzle strikes the bucket's vents of the runner so that the runner rolls at a very high speed and generates electricity. This machine is one of the hydroelectric machine. The second one is the abrasive water jet cutting. Abrasive water jet cutting use an abrasive particle, e.g. garnet, added to high pressure water to cut through hard material. I think that's all for me. Thank you.
The conclusion in this experiment is the purpose of this experiment is to compare the force exerted by a fluid jet impinging upon a flat plate or hemispherical surface with the theoretical value. In this experiment, we can conclude that the force exerted on the hemispherical plate is greater than flat plate. They also have a difference between the actual and the theoretical value due to some errors. The average of percentage of relative error of hemispherical surface is higher than flat surface. Last but not least, these are the references that we use to complete this experiment. Thank you.